Let's go ahead and create a, matrix object. Um, as always, we've started by creating a main function, and we all already created a reference to let's see, to the dog waffle exe there, and all that. We've got that out of the way. We went ahead and did a save undo. We created this dog waffle object, of course, from the dog waffle class, just so we'll have those functions available to us. We did a refresh and all that stuff. That's all the stuff we do in all our plugins or all our code here. So we'll have that stuff available to us. Anyways, let's begin and declare matrix as new VB matrix. And let's look at some of the things that we can do with this. First of all, we could create a basis matrix. And what we're looking at here is, in fact, a basis matrix. If we did that, we could probably uh, let's see. Should be get matrix elements. Not exactly sure. Yeah, that will get all of the elements. Let's see. I was hoping I could. Well, anyways, if we were to print out all these elements, that would take too long to write. But if we were to print out all those elements, it would look kind of like this: 1 0 0 0 1 0 0 0 1, etc. If we did this basis matrix, and that's kind of a place we could start. Now, say if we wanted to translate something, we have a set of points or some a bitmap or something. We want to rotate it or translate it. We can go ahead and set up our matrix to do that, and then we can later go ahead and apply it to the points or apply it to the whatever we want to apply it to. So let's do m dot translate, and you can put some values in there. But the problem with that is it'll overwrite our basis matrix, or it'll overwrite the previous thing that we've done. Say we did a translation, and then we did a rotation, and then we wanted to do a scale. Well, that would overwrite the previous thing we did to this matrix. So what we need to do is m dot concat, which is short for concatenate, and then we can do the translation or the rotation in the matrix, and this will build up these layers of or it'll multiply one matrix by the other basically, and will it'll keep the previous translation or the previous transformation and apply the new one to it. So let's translate something by 10, 10, 0. Let's add some rotation, and I believe this is in radians. So let's see, pi divided by 2. I haven't actually defined pi, so I'll just use some random number, 0.001, comma 0, comma 0, etc., etc. M dot concat scale. Say you wanted to scale something, 0.5, comma 0.5, comma 0, whatever. Um, and at that point, we have our matrix set up, and then we'd probably want to do something with it. So let's say we had a series of points, and there's 100, make that 99 because that's the upper bound, and 2, so it'll be, the upper bound is 2. That means you'll have 0, 1, and 2, so you can have x, y, and z basically as single. And I don't know, I'll just fill these out with random values for now. Then in the future we can do maybe a more practical example. But just to show this. Alright, then that's fine. So we've initialized this set of points with some random values. Now let's go to this m object, the m dot apply to xy or apply to xyz buff, and we'll pass that points into it, and we'll pass the count into it, which is I believe 99. The count is actually 100 because that's the upper bound. So there's actually 0 through 99, so the count would be 100. All right, and that's basically it. We apply this matrix where we've done all these different things to it, rotation, scaling, and translation, and we apply it to these set of points, and we run it, and hopefully that works. Whoops, let's see, typo, couple of typos, and hopefully that works for us. Yeah, sure, no problem, it worked for us. All right, so until I come up with a proper uh, something we can actually do on screen to look at, that's basically what you can do with a matrix: rotation, scaling, translation of a set of points, or something to that effect. Bear in mind, in this matrix class is used internally. It's used by the drawing class. It's used by the geometry class and a lot of other places. Just be aware that that's in there and kind of working for you in the background. Um, when you're in the drawing class and you do a push matrix or a pop matrix, this is what you're pushing and popping basically. Or if you do a reset matrix, what you're doing is basically creating a basis matrix, a matrix with no transformations applied to it. Or as we said before, it's just resetting the coordinate system back to that original, Cartesian, whatever coordinate system, like that. Or no, that should be Y. But anyways, I'm a I'm a Y up kind of person, I think. I don't know. Anyways, so thanks for watching. That was our introduction to the Matrix class, and not sure what we'll talk about next, but stay tuned, and we'll come back later.